let's think about something for a second. Have you ever considered the actual physical weight of a thought? I don't mean in your head. I mean in the massive digital world we've all built. Today, we're going to connect the dots between the fundamental energy of the universe and the information on your screen. And we're going to ask a really radical question. What if the future of our economy isn't the dollar, but the joule?
So, to really wrap your head around this, just look at this comparison. On one side, you have the energy that a single major data center burns through in a year, and on the other, a whole city, a big, living, breathing city like Bordeaux, France. And here's the crazy part. Their energy consumption is pretty much the same. This isn't some weird outlier. This is the world we live in now. Our digital universe has a very real and, frankly, enormous physical cost.
And that really gets to the heart of what we're exploring. We love to think of data and information as being, well, immaterial, right? It's just in the cloud, weightless and free. But what if that's just a massive misunderstanding? What if every single Google search, every video you stream, every image an AI creates has a physical price tag we've just been ignoring? All right, so let's start tearing down this illusion that computation is somehow free or weightless. Because the truth is, every single digital action you take has a price, and that price is paid in energy. This really requires us to shift how we think about computers. A calculation isn't some abstract, magical thing, it's a physical transformation. A machine literally takes in electrical energy and uses it to force tiny bits of matter into an ordered, meaningful pattern. And that whole process? It's bound by the unshakable laws of physics. This quote just nails it perfectly. We are, quite literally, witnessing the transmutation of heat into thought. We're turning raw energy into ordered information. Now that might sound like poetry, but it's not. It is the most precise, scientific description of what every single server on every rack all over the world is doing right this second. Okay, so what's the actual science here? To really understand why information has a cost, we need to talk about one of the most fundamental concepts in all of physics: entropy. Now here's the brilliant part. Entropy is the bridge that connects two completely different seeming worlds. In physics, right, it's this unstoppable tendency for things to become more disordered, to lose energy as waste heat. But then this genius named Claude Shannon came along and realized entropy could also measure uncertainty in information. So to create information is to reduce uncertainty, to create order. And here's the catch. The laws of thermodynamics tell us that you cannot create order in one tiny spot without creating even more disorder, more heat, more chaos everywhere else. And this slide shows that trade-off perfectly. You start with raw electricity. The computer does its thing, performing a calculation, and bam, you get informational order, a specific, non-random answer. But the unavoidable price of admission is all that dissipated heat, which increases the physical disorder, the entropy of the whole system. There is literally no such thing as a free calculation. It always costs something, somewhere. So the question is our super hot, high-energy method the only way to do this information processing thing? Well, if you ask a nature, she might have a very different answer. Let's look at a pretty mind-blowing comparison. I mean, think about what we've built. It's incredible. A digital nervous system that wraps around the entire planet. We've got fiber optic cables running under the deepest oceans, satellites beaming information down from space. It's a true marvel of engineering. But, and this is the amazing part, it turns out we weren't the first ones to come up with the idea of a network, not by a long shot. For millions of years, entire forests have been linked together by this massive underground web of fungi. These mycorrhizal networks are a biological internet, letting trees share food, water, and even send out warning signals to each other. And when you put the two networks side by side, the difference is just staggering. Our network is blindingly fast, it's global, but it comes at an absolutely immense energy cost. Nature's network is local, it's slower, but it runs with the kind of quiet efficiency that's almost beyond our ability to comprehend. It's perfectly woven into the energy of its environment. This chart just drives the point home. It's not even a fair fight. Look at photosynthesis. That's basically nature's version of computing with sunlight, and it's almost perfectly efficient. Then look at the brute force energy we have to pump into a complex AI calculation. We've built something incredibly powerful, there's no doubt about it, but we have not yet built something wise. Okay, so all of this leads to a pretty radical conclusion. If energy is the real foundation for everything we do and everything we value in this new digital age, Well, what if we started measuring value itself in units of energy? Let's put this into a bit of historical context. How we define value has always been changing. We started by just bartering actual stuff. Then we moved to a scarce metal like gold. And now we're on a system based on fiat currency, the dollar, which, when you boil it all down, is based on our collective trust in an institution. So, what's the next logical step for a civilization that runs on computation? Maybe, just maybe, it's a value system based on the one thing that truly underlies everything: energy. And that's the proposal right there. The new unit of value could become the joule, the fundamental international unit of energy. So what on earth is a joule economy? Well, it's a system where the worth of a service or a product or even an idea is directly connected to the actual physical energy it took to create it. No more abstraction, just pure thermodynamic accounting. A new car's value wouldn't be about the brand. It would be the sum of all the joules it took to mine the metal, ship the parts, and run the factory. And this is where things get really philosophical. Because if we actually go down this road, what does it mean for us? What is the energetic cost of just being human? I mean, really think about that. That aha moment you have, that flash of pure creative genius. Your brain is consuming a tiny little bit of energy to make that happen. In this new world, that idea would have a literal, quantifiable thermal value. And suddenly you're faced with these impossible questions. The emotional resonance of a poem, which cost almost nothing in terms of joules to write, does it have less value than a complex algorithm that took a supercomputer weeks of nonstop work to figure out? How do you even begin to measure the unmeasurable? This is the ultimate ethical crossroads, isn't it? Do we really want to march down a path where every creative act, every intellectual breakthrough, every spark of human genius gets reduced to its raw energy cost? Is that the future we actually want to build for ourselves? Okay, let's pull all these different threads together for one last big thought about what we're actually becoming. When you zoom way, way out, this is what humanity is up to. We have built a single global machine, a kind of planetary metabolism that is just sucking in unbelievable amounts of energy and breathing out information, computation, and digital order. We are fundamentally changing the planet's energy flows to power a new kind of intelligence. And so that leaves us staring at this one final question. In a vast cosmos that's governed by the laws of energy and the unstoppable march toward disorder, what is our role? What is this intelligence of ours? Are we just another fancy, complicated way for the universe to dissipate heat? Or is the information we create, the art we make, and the thoughts we think something more? For now, that is the question we all have to answer.